From the Library of Congress in Washington, D.C.
Ladies and gentlemen, please welcome the Librarian of Congress, Dr. James H. Billington.
Good morning, ladies and gentlemen. I'm Jim Billington, the Librarian of Congress, and it's a great pleasure to welcome you all to this event that celebrates the life and work of the great and outstanding American scientist and science communicator, Carl Sagan. Today, the library is opening to researchers the voluminous Sagan papers, formerly known as the Seth MacFarlane Collection of the Carl Sagan and Anne Druyan Archive. So on behalf of the library, I want to thank Samson Galaxy for its support of today's celebration, Seth MacFarlane for making it possible for the library to acquire and make accessible the Carl Sagan and Anne Druyan Archive. We thank Anne Druyan especially for her constant support, inspiration, and guidance about the archive. And we thank all the speakers that are with us today. Carl Sagan's special stature and role in the history here enables us to bring together an outstanding group of science and science communicators and educators in a time of great concern about enhancing our national skills in science, technology, engineering, and math. I also finally want to thank Jim Hudson, the chief of the library's manuscript division, and all the dedicated archivists here who worked hard to organize and describe the Carl Sagan and Druyan Archive, making it accessible to researchers. In addition to the distinguished members of Congress and staff who have enabled us to amass our wide-ranging scientific collections, we have with us today scientific thinkers from a variety of fields, producers of film and television programs about science, science educators, leaders of scientific organizations, Einstein Fellows, science writers, and students. Science has always been a large part and a crucial part of the library's collection in 470 languages. Papers of innovators like Samuel Morse, Alexander Graham Bell, Wilbur and Orville Wright, J. Robert Oppenheimer, and a host of other American scientists, as well as the earliest published works of Copernicus, Galileo, and other early innovators of modern science, whose works are, that are on display here are in your program and will be seen later in the day. So it's exciting that the rich Sagan-Druyan archive, 595,000 items, now joins the great selection and collection of scientific knowledge from various time periods, cultures, and disciplinary subdivisions of science and engineering that are here in the nation's library. We now are aware that the information contained in the Sagan-Druyan archives will be available for the education and inspiration of the next generation of scientific thinkers, representing an ongoing memorial for the absolutely unique science exciter of our time, Carl Sagan. It's now my honor to call Seth MacFarlane, to whom we owe much, to the podium to launch the day's important proceedings. Mr. MacFarlane.
Place is way too classy for me. For some reason that escapes me now, I was watching a rerun of Sequest last week. For those of you, if you don't know what that is, Sequest was a science fiction program back in the 90s about a state-of-the-art submarine whose mission was to explore the uncharted regions of Earth's oceans. It starred Roy Scheider and a cast of actors who I'm sure all bought new cars midway through season 1 before they discovered they were on a terrible show doomed to be canceled. The point of this is that one of the crew members was a super smart dolphin named Darwin. And as I was watching the show, trying to decide whether to swallow the whole bottle of sleeping pills now or during the end credits, it occurred to me that if this show were made today, two things would be different. One, Roy Scheider's character would have a meth addiction. And two, the name Darwin would probably be changed to something else. There would be a conversation among network executives that the name Darwin might be too polarizing or too politically charged. They wouldn't want to turn off or alienate a significant portion of their audience. Somewhere between the 1990s and today, the acknowledgement of scientific achievement and the embrace thereof ceased in many parts of this country to be a source of pride and became a taboo specter with threatening overtones. Now, while there is absolutely no defensible reason for this to have occurred, we all know how it occurred. Now, science has always been, as we know, exploited and politicized in some form or another. But in the past 10 years or so, it seems like that politicization has been on steroids. Long accepted scientific truths have been brought into question, largely, who are we kidding, by one side of the aisle, solely for the purpose of generating passion that can be reshaped to suit various agendas. And the other side of the aisle has not really put up much of a fight. Instead, they've allowed the situation to fester instead of leading us back to the truth as a leader should. By fearing for political standing instead of fighting for the truth, they have essentially revealed the same fear betrayed by those hypothetical network execs who were nervous about naming a talking fish Darwin. I guess they're mammals, huh? Anne? And unfortunately, the press has done little to help repair the damage. They routinely report the noisy ravings of fringe-level anti-science bellowers who would not even have been on Walter Cronkite's radar, let alone press-worthy. As a result, a nationwide scientific regression has taken place. We should be in the midst of an excitement-filled national discussion on the frontiers of science, such as the fascinating concept put forth by quantum physics that the universe may have been conceived by a quantum fluctuation in one of the higher dimensions of the space-time continuum. Instead, we're still trying to get people to understand that as personally uncomfortable as some may find the fact, we all evolved from Robin Williams. At some point during all this, someone has to stand up and loudly say, all right, enough, cut the crap. First of all, evolution really happened. It's not in debate. Some of the milestones along the way are still being uncovered, but it doesn't mean that a member of Congress should suddenly get to call the whole thing into question. I've never seen gravity questioned or politicized in any way. And in the grand scheme of the universe, we probably understand gravity less than we understand evolution. It just doesn't make people as uncomfortable. So it's a less effective tool of manipulation. Now, there have been many reasons for this cultural shift, and while it may not have tipped the scales, one thing is certain: we took a big, big hit when we lost Carl Sagan. Here was a man of science who was regularly in the public eye. He used to appear on The Johnny Carson Show alongside big stars like Harrison Ford, Bill Cosby, and Jerry Van Dyke. Yeah. And he belonged in the spotlight. He was a great popularizer of science, a man who understood that scientific advancement is something that affects us all on a daily basis, whether we're aware of it or not. He knew that if there's a walled-off separation between the academic world and the public at large, it doesn't do anyone any good. It was partially thanks to the efforts of Carl that the case of science phobia, from which we suffer today, had a much harder time proliferating in the decades prior. He translated for those of us who don't even remember how to use a protractor. He not only found creative ways of explaining dense scientific concepts to us without ever appearing condescending or superior, but he did so with such an obvious passion, enthusiasm, and love for the subject matter that it was impossible not to want to go along for the ride. With Carl, it wasn't, we evolved from microscopic organisms, that's scary and unsettling. Instead, it was, we evolved from these incredible, fascinating, totally alien-seeming creatures. Isn't that amazing? You want to know more? Yeah, so do I. Let's try and learn the answer to the mystery together. Which is another thing I always admired about Carl. He tended to speak less in terms of us as a country and more in terms of us as a species. He was truly a man who thought ahead of his time, and honestly ahead of our time as well. Now, I never had the chance to meet Carl, which I greatly regret, but I've been lucky enough to befriend and later work alongside his wife, Anne Druyan, whose blinding brilliance, unbounded imagination, and incredible strength of character have made me feel as though I know them both. She's one of those people whose brain is so formidable and so constantly bursting with new ideas that I'll tell you, if I were that smart, I would have to smoke pot too. Sorry, Anne. I mean, we're what, like 6 months away from legalization? It's fine. The work that Anne has done on the new Cosmos series is, I can tell you now, everything we all hoped it would be and more. And the series is, of course, hosted by the brilliant and charismatic Dr. Neil deGrasse Tyson, who has emerged as the heir apparent to Carl's rare combination of wisdom and communicative power. Anne continues the work that she and Carl began together in full force, and it is not only my privilege to know her, but I am a better man by the association. So let me say I am thrilled and humbled to be connected in some tiny microscopic way to the extraordinary life's work of Carl Sagan, a man who opened my eyes and the eyes of millions of others to the ever-expanding wonders and mysteries of science. Thank you.
Please welcome to the podium Dr. Christopher F. Chyba with his message of science and hope.
Good morning. Even after all these years since Carl Sagan's death, it is a melancholy honor for me to have been asked by Anne Druyan to be here this morning to say a few words about Carl and about the world we live in. But I am thankful to be asked. I miss Carl greatly, and I think our country misses him more than it knows. In his 1995 book, The Demon-Haunted World, in a chapter titled Science and Hope, Carl wrote, "We've arranged a global civilization in which most crucial elements profoundly depend on science and technology. We have also arranged things so that almost no one understands science and technology. This is a prescription for disaster. We might get away with it for a while, but sooner or later, this combustible mixture of ignorance and power is going to blow up in our faces." I want to talk briefly this morning about this problem, and I want to make the case that, as worrying as the problem Carl identified is, there is a reverse problem that might be just as dangerous. As an example, to make this concrete, let me recall an experience of about a decade ago. Over the span of a couple of weeks, I gave what was supposed to be the same policy-oriented academic talk in 2 different venues. The first was in Washington, D.C., at a leading foreign policy think tank. The second was in California, at a leading biotechnology company. The subject of the talk was the challenge posed to international security and to all of our securities by rapid advances in biotechnology. In particular, I was concerned, I still am concerned, about the opportunities that the exponential increase in the power of biotechnology could confer on small groups of bad actors to undertake potentially extremely dangerous manipulations of microorganisms. These capabilities are literally exponentiating at a Moore's law-type pace, as measured by various metrics across time. Most Cold War-style arms control approaches seemed, and still seem, inadequate to the challenges posed by this new world. The DC think tank was populated, as DC think tanks will be, by the recently out of power and the hoping soon to be back in power. Policymakers, or those who might soon once again make policy. Among them, there were a few people who were quite knowledgeable about biology and biotechnology, but not most. I could assume that pretty much everyone present knew the Biological Weapons Convention, the multilateral treaty that endeavors to prevent the development of biological weapons. Most would know the story of the failed decade-long effort to negotiate a compliance protocol to the convention, but most would not know a great deal about molecular biology or biotechnology. At the biotechnology company in California, the reverse situation existed. This time, I asked, to a crowded auditorium of scientists and technicians, not which of them could identify, say, the polymerase chain reaction. All of them understood it much better than I did, of course. But rather, how many of them were familiar with the Biological Weapons Convention? Several hands went up, including that of one of the company's executives. It could have been worse. But only several hands in the full auditorium were raised. So among these scientists who were devoting their careers to the useful employment of biotechnology, nearly no one was familiar with the international treaty intended, however inadequately, to prevent harm from that technology. A decade later, at Princeton University, I had a similar experience, but one with a gratifying outcome. A senior biologist and I were talking at an outdoor barbecue with our kids. He lamented how little biology policymakers in Washington seemed to know. I agreed with him, but then noted that my experience was that the problem also ran in the opposite direction, that most biologists did not know much about, say, the Biological Weapons Convention. My colleague admitted that he was in that group, and then he did a terrific thing. He decided on the spot to change this, and henceforth to include a lecture on biology and bioterrorism as a component of Princeton's big undergraduate biology course. So the reverse side of Carl's concern is that there is too often a lack of knowledge by scientists of policy and policymaking. There are some areas of science where the policy issues are at the cutting edge of scientific research and are embraced by the relevant communities. I think climate change is an example of this. But there are many other areas where the relevant scientific community is not strongly enough engaged, or sees only potential restrictions on its freedom from government action, or even punishes those who stray too far into policy. Young scientists get the message by watching the behavior of their elders, and the message too often is, the world may be haunted by demons, but they can wait until you have tenure. I think that scientists, universities, and scientific bodies are all getting better at this, but they need to get a lot better. Carl's career displayed one model. After some very early experience with formal government advising, he became increasingly involved in policy, but from a base outside the usual advisory committee structure. He had the stature to speak to principals directly. He also had the stature to involve himself directly with his Soviet colleagues in so-called Track 2 diplomacy. There's an evocative picture of which I'm quite fond in Richard Rhodes's book Arsenals of Folly, titled The Scientist's Back Channel. The picture shows Carl Sagan and Anne Druyan together with Dick Garwin over dinner with a Soviet colleague. I remember a diplomat formerly at the US Embassy in Moscow saying to me that Carl could irritate people at the embassy. He sure could irritate people at the embassy, but that he was respected there nonetheless because they recognized, as the diplomat put it to me, that Carl was nobody's fool. He would stand up to his Soviet colleagues or the Soviet government in the same way that he would stand up to his own government. For most scientists, though, the same opportunities won't be present at that level. Most of us will not have the individual stature to insert ourselves at a point of our own choosing into domestic policy making or international diplomacy. There need to be models for the rest of us. And for many, that will mean service on government committees or on scientific society committees or within the government itself. My concern here is not with scientists serving the scientific community, as important as that service is, but with scientists serving, if you will, the policy community. We need scientists operating at every point along the policy advising spectrum. Now, Carl was a great optimist, and I want to close optimistically. Every year, there is a flood of young scientists who apply for the policy fellowships offered by our country's scientific societies. Anyone who is familiar with Capitol Hill or with the executive branch knows the role that these fellows play. So the dedication to service is already there. We just need to work to ensure that our universities and professional societies, but especially our universities, welcome that dedication. Surely we can do that. As Carl urged in The Demon-Haunted World, let's teach both science and hope. Thank you.
Please welcome to the podium Dr. Ralph J. Cicerone with the message "From the Faint Early Sun Paradox to the Bright Star of Science Communication."
First, on behalf of everybody here today, I want to thank the Library of Congress, Seth MacFarlane and Druyan for bringing us together today in a very enthusiastic occasion. I want to talk very briefly about what I saw as some of the passions and intellectual pursuits of Carl Sagan. I think all of us know that he was very interested in the universe, its size, its characteristics, what's in it. I want to talk about a couple of other ones, though. His lifelong interest in life on Earth and on other planets. I'll call it the habitability of the Earth. And then finally, his enormous enthusiasm for learning and teaching of all kinds, which we kind of summarized by saying science communication, but it was really a fascination and a commitment to learning and teaching, I think. First of all, on Earth habitability. In 1972, Carl published a paper which is still regarded as a major landmark. In fact, last week I found an enormously scholarly paper carrying on in great detail and in progressively finer detail an important idea that Carl had. It was the following. We've learned a lot about how stars behave, and they evolve with time over billions of years. And in the case of our own sun and the class of stars that it belongs to, there's very solid evidence that the sun used to be dimmer, say 3 or 4 billion years ago. Perhaps 30% less light and energy was coming out of the sun. That's fact number one. Fact number two is you can then do a simple physics calculation, which had been done well by that time. How warm would the Earth have been in those days? What would the temperature be? And the answer comes out, it would be frozen solid. But there's also geological evidence that that's never been the case in the history of the Earth, so something's missing. Something is either wrong or missing. And Carl and his colleague Mullen had the idea that there might have been an early greenhouse effect in the atmosphere of the Earth, and Carl was particularly interested in ammonia as a gas, because there was reason to believe in those days and now that ammonia was important in the origin of life on Earth as a base for amino acids. So they did calculations on just putting a little bit of ammonia into the primitive atmosphere, and sure enough, they could raise the calculated temperature of Earth above freezing. And this was a major contribution. Today, the topic is more complicated. We think we'd need a little bit of methane and carbon dioxide as well, but it was an important contribution, all driven by what is it that makes this planet habitable and how has it changed? The second topic is not so cheery, and that was the nuclear winter. Many of you know that Carl was very involved in the early 80s in trying to calculate and figure out what would happen in a fairly large nuclear exchange of weapons between, for example, the two superpowers. And there had already been some findings that a lot of dust and smoke would be lofted into the air, largely from fires in cities, such as happened in the firebombing of Europe in the Second World War. But what no one had thought of yet is that dimming of the sun, what would its effects be on the Earth's climate? And there was a major paper that was published by Carl and his colleagues, referred to as TTAPS, because it was Turco, Toon, Ackerman, Jim Pollack, and Carl Sagan in that order. And I was a reviewer of that paper, and it was quite stunning. And I remember writing, "Publish without delay," in my final comments. What they had figured out was that this smoke would be lofted by the buoyancy of the heat to very high altitudes and could actually block out sunlight for a period of months, certainly a growing season, maybe longer. Not only would it cut off food supplies, but it would cool the entire Earth and launch what people referred to then as a nuclear winter. Well, the science was good, but Carl carried it into the public domain. He wrote op-eds for magazines, newspapers, the journal Foreign Affairs, Nature magazine, Science. I don't know how many times he talked on Johnny Carson's show about it. But the point was that even the winners in a nuclear war would lose, because at least a hemisphere of the planet, if not the half the planet or more, could be harmed in this way climatically. So it was this is a cover of a book that he wrote with my friend Rich Turco, which never made the bestseller list, but it gives an enormously detailed and important documentary of the thinking they had gone through. As you see, a path where no man thought was quite stunning. And it was, I think, a major contribution. The question is still not settled. Fortunately, we haven't had to confront the actual experiment. Finally, let me say a word about his teaching and learning. As people know here very, very well, he was an enthusiastic communicator, just all over the world. He enjoyed it, he knew he was good at it, and he felt a responsibility. A personal experience I'll share from 1970, I think it was the first time I met Carl, and we were off on an afternoon walk after a formal presentation, and he told me a trick that he had discovered. He was doing a lot of traveling even then, and he would go into hotels where he was lodging and try to speak with the general manager or whoever was in charge and convince that person that if they would give him free room and board, he would speak in the lobby of the hotel. And he was so good at it that he engaged all kinds of people, and the managers, when word of mouth spread, they did it for him quite a bit. So that was great. Of course, the magnificent achievement of the Cosmos series, which we're going to hear a little bit more about, that Seth MacFarlane just mentioned, that there's going to be a new Cosmos series, leads me to thank him for all that he did and the great parade that he's created now with wonderfully competent and original and innovative people who are carrying it on. Some of the people like Neil deGrasse Tyson and Seth himself and Janet and Jerry Zucker, who are here today, people who are really carrying this on because they believe some of the quotes that Chris Chyba just read about what Carl believed is the enormous challenge that we have in the world we live in, and yet how much better it can be. So thank you for the opportunity to be here. It's a pleasure.
Please welcome to the podium Dr. John P. Holdren with his message of creating a science-savvy citizenry.
Well, first let me convey my thanks and those of President Obama to Ann and Seth, Dr. Billington, and others here at the Library of Congress for making this event possible. It's really great to see such an extraordinary array of luminaries here to celebrate the exceptional scientist, educator, communicator, guide to the cosmos, and inspiration who was Carl Sagan. While the President couldn't make it today, I can tell you that he is committed to the same goals in science, the education of kids and the public about science, and the exploration of the cosmos that Carl so effectively espoused. Committed, that is, to ensuring that these great endeavors get the federal and societal support that their importance to the human enterprise warrants. Supporting President Obama in that commitment comes naturally to me, I'm happy to say. My interest in and passion for science and for space goes back a long way, and was boosted along the way by a number of interactions, first with Carl's work and then with the man himself. In grammar school in the 1950s, I was reading about Robert Goddard and making solid rockets using drugstore chemicals and my mother's discarded lipstick tubes. At MIT in the 1960s, I majored in aeronautics and astronautics and co-led that major's senior class project of designing a manned Mars mission. And in graduate school at Stanford in the late 1960s, my interest in the search for extraterrestrial intelligence was sparked by Carl's remarkable 1966 book with Joseph Shklovsky, Intelligent Life in the Universe. I first met Carl in 1972 when I was at Caltech working with the late great geochemist and scientific statesman Harrison Brown. Carl was there to give some lectures, and the Browns had a dinner at their apartment for Carl and his then wife, me and my wife, and the chair of the Caltech Geology and Geophysics Department, Barclay Cam, and his wife. What I remember most about that dinner was Carl talking animatedly about the work he was doing to develop the images, sounds, and symbols about human beings and our Earth to be inscribed on gold-plated copper discs that would be carried into interstellar space on the Voyager 1 and 2 missions. Carl, Frank Drake, Ann Druyan, and others later produced a book called Murmurs of the Earth about those messages, made in the hope that one of the Voyagers would someday reach another civilization. Carl and I met on many occasions after that evening in Pasadena, and on every such occasion, I learned from him. He was a first-class scientist with a wide-ranging intellect and also an extraordinary gift and passion, as we all know, for communicating the content and the excitement of science to people of all backgrounds and ages. I want to use the rest of my few minutes here this morning to talk about how and why the kind of communication and inspiration that Carl was so good at providing is so important to advancing the Obama administration's priorities around science, space exploration, and science, technology, engineering, and math education today. The President has often said that the single most important thing we can do for the future of our country is to lift our game in STEM education. And he knows that there are three aims that are served by doing that. One is to educate and train the next generation of discoverers, inventors, and innovators, the winners of Nobel Prizes and National Medals of Science and of Technology and Innovation, the founders of new high-tech industries, the next Harold Varmus and Gordon Moore, and maybe, if we're lucky, the next Carl Sagan. A second aim is to ensure that we have the technologically capable workforce that the jobs of the 21st century increasingly require. And the third is to produce the science-savvy citizenry that a well-functioning democracy requires in an era when more and more of the consequential issues before our elected officials have significant science and technology content. That third aim sometimes gets less attention than the other two, but it's arguably the most important of the three, not least because only with support from a science-savvy citizenry will society make the investments that achieving the first two aims will require. Investments in STEM education, in basic research and the research universities that do most of it, in public-private community college partnerships for workforce training, and in scientific infrastructure, including high-speed computing, Earth-observing satellites, and space telescopes. Carl, of course, knew all this. He knew that for these reasons and more, a science-savvy citizenry is essential for contemporary society's success, sustainability, and perhaps even survival. He understood that prosperity and public health would ultimately be at risk in a society half of whose members denied the fact of biological evolution. He knew that the degree of collective action needed to avoid unmanageably disruptive global climate change resulting from human activities would not materialize if too few elected officials understood its reality and its impacts. He would have loved President Obama's comment in rolling out his climate action plan last June that, quote, "We don't have time for a meeting of the Flat Earth Society." And Carl knew that the political will to shrink nuclear arsenals and abjure their use would materialize only if a majority of citizens came to understand what science tells us about the consequences of a nuclear war. As we here all know and have gathered to celebrate, Carl Sagan acted on his understanding of the need for a science-savvy citizenry, and he did so with unparalleled style and effectiveness. He was a tireless, impassioned explainer, teacher, and mentor, infused with and relentlessly propagating excitement about the Earth, the cosmos, and human possibilities. I only wish he were still with us. I can almost hear him now, explaining to a captivated global audience of all ages that thanks to the Kepler project, we now know that there are not only billions and billions of stars in our galaxy, but also, in all likelihood, billions and billions of Earth-like planets. Thank you very much.
Please welcome to the podium Dr. Jonathan I. Lunine with his message of Letter from a Hero.
This is the first edition of The Cosmic Connection by Carl Sagan, and I bought this book in 1973 at the age of 14, having read about it in Sky and Telescope. And I read this book, of course. I read it very quickly, and I was transformed by it. I thought I knew about astronomy as a 14-year-old nerd. I didn't. Carl showed me what astronomy and what humanity's place in the universe really was. And I was so excited by this book that I would run around the house and read excerpts of all 39 chapters to members of my family. My mother stopped this insurrection by saying to me, "Why don't you just write to him?" I said, "Write to who?" "Carl Sagan." I said, "He's not going to read a letter from me. I'm just some 14-year-old nerd." My first date, was in a polyester suit, and the date ended really early, too. So she said, "Write to him." So I did, and it was agonizing to try to put this together on lined yellow paper. Well, a few weeks later, I got this, which was a letter and reprints from Carl Sagan. So the letter, which I actually have here, looks like this. It's 2 pages, 2 pages. Personally written by Carl Sagan. And Carl got right down to business because I asked him, "How do you become an astronomer?" And Carl said to me, and I'll read it from here because this monitor doesn't work. He talked about astronomy as in fundamental sense an application of mathematics and physics. In graduate school at Cornell, we often accept students who have excellent undergraduate backgrounds in mathematics and physics, but have never taken a single course in astronomy in their lives. I didn't know that, so the key was to focus on physics. Carl provided that information to me. He then went on the next page, to say, "I think your dedication to astronomy is admirable and should be encouraged." And of course, I read this about 30,000 times to myself. So I realized at this point that I really could become an astronomer. Now, that being said, and having been interested in astronomy from my youth, I actually lost courage. In the mid-1970s, the economy was terrible. PhDs in physics were driving taxi cabs. And so I decided that I should be instead a medical doctor. And I wrote to Carl Sagan. So Carl, in his understated way, steered me gently back to astronomy by saying, on your career plans, medicine is a quite respectable profession, and note that there are important opportunities in medical research which carry some of the frontier excitement of astronomy. So that brought me back to astronomy after a while. Now, years went by, I went into graduate school and so forth, and unbeknownst to me, in the mid-'80s, my mother wrote a letter to Carl Sagan, wanting to make sure that he knew that I actually went through graduate school, got my PhD, and I was working. And so Carl wrote this letter back to my mother. I mean, did he have time for this? So, first of all, he said how much he appreciated the letter. He then said that the accumulation of his mail has reached such a state that he's not answering as many letters from younger versions of Jonathan Lunine as he should. And he says the letter reminds him of the importance of finding ways to write to youngsters. And then he makes this undeserving compliment at the end, which is to say, if I've helped inspire Jonathan and taught him something about planetary science, he has certainly returned the favor. Now, I'm not putting this up here to brag, because I have a point to make about this. First of all, Carl's letters have the clarity and eloquence that his books do as well. He had an amazing dynamic range in his ability to write. He could soar lyrically in his books and his TV interviews, and then he could write clearly and eloquently to a 14-year-old about what to do in order to become an astronomer. His letter to me was not remote, it was not condescending, it was collegial in an honest way, and it was remarkable for that reason. And he didn't enclose a picture of himself in that letter. He enclosed 2 reprints of articles about Phobos and Deimos from the Mariner 9 mission. So, he knew a nerd when he saw one. But I gobbled up those letters as well. And the letter to my mother, I think, is even more remarkable because it really begins with almost a kind of lamentation. I found out years later how many of my colleagues he wrote to when they wrote to him as younger people. And Anne said that he had stacks of these. And he just, being a human being, he couldn't do an infinite number of these letters. And he lamented that fact because he knew how important it was. And then in the last part, he says something that, in effect, is what Francis of Assisi said. It's in giving that we receive, but for an important reason. If humanity is to save itself from itself, it has to grow to become aware of its real connection to the cosmos, its scientific connection to the cosmos, and its fragility as a planet-bound species. And of course, Carl knew this. We all know that Carl knew this. But he also knew that the consciousness of this fact was not growing, and it was shining only dimly in the society of his time and, of course, of today. And so nurturing the next generation to be conscious of our place in the cosmos was his most important responsibility and the most important contribution he gave to humankind. And he knew that, and part of that was nurturing young scientists to become the Carl Sagans of the next generation, like Neil deGrasse Tyson. So he nurtured people by writing these letters, and he ensured that there would be scientists coming up in the future who would do what he had done. So Joseph Campbell said that a hero is someone who has given his or her life to something bigger than oneself. And this exemplifies Carl perfectly. He was a hero. He gave everything to the public, to his colleagues, to his students, and to students yet to come. So for that reason, I am really, really glad that Anne Druyan, his creative partner in so many of his beautiful books, has been working with Steve Soter, with Neil deGrasse Tyson, with Seth MacFarlane, to make Cosmos 2 a reality. Maybe that will allow us to push the reset button on this and give all of us a chance to make this truly a science-savvy and science-knowledgeable species. Thank you very much.
And now a brief film clip.
Carl contributed enormously to our knowledge of the planets. He correctly predicted the existence of methane lakes on Saturn's giant moon Titan. He showed that the atmosphere of the early Earth must have contained powerful greenhouse gases. He was the first to understand that seasonal changes on Mars were due to wind-blown dust. Carl was a pioneer in the search for extraterrestrial life and intelligence. He played a leading role in every major spacecraft mission to explore the solar system during the first 40 years of the space age.
Please welcome to the podium Dr. David Morrison with his message of Carl Sagan, the People's Astronomer.
Thank you. It's wonderful to be here to honor Carl. I was one of his first graduate students, and he mentored me through my whole career. So it's great to have this brief opportunity to thank him and to thank you. Carl was born at the ideal time. He was a person for his time because he was there to be our guide through the initial exploration of our solar system. As he said and wrote many times, there's only one generation that could begin when the planets and their moons were simply faint points of light and could watch each of them emerge as a true place with its own geology and perhaps biology as well. We sometimes forget what an excellent scientist Carl was. He published more than 300 peer-reviewed papers. He was the mentor to a large number of graduate students, some of whom are on this program. And he brought together fields as diverse as astronomy, planetary science, including geology, and biology. It was really quite remarkable for an astronomer to be interested in biology as well. In fact, it was remarkable to be a planetary scientist when he began. Most astronomers considered planetary science very nearly beyond the pale, and biology, oh my, that wasn't legitimate at all. But he brought all of these ideas together in a unique way. He was the right person at the right time. He also, as we have noted, was a wonderful teacher. And I've seen him many times speaking to public audiences as well as classes, always willing to answer questions to the best of his ability. Sometimes it gets sort of amusing. Once he was giving a talk out in California, I'd introduced him. It was a good talk. And in the end, one member of the audience got up and asked a question whose obvious answer was billions and billions. And of course, Carl said he'd never used that phrase. So they went back and forth, and Carl did not answer billions and billions. And the person kept repeating the question. And finally, Carl held up a finger and said, "I know what you want me to say, and I'm not going to say it." Another aspect of Carl that is so different, but is ultimately founded on his scientific expertise, was his interest in social and political problems, and his contributions to world peace, some of which were successful, some not. He really seriously hoped that there could be a joint US and Soviet human mission to Mars, not only as a way to advance science, but also as a way to bring the two superpowers together. I remember once sitting in a scientific meeting at the Space Research Institute in Moscow, and suddenly here comes Carl Sagan and Robert Redford walking past. They waved and went on doing their thing. He was an international figure by then. We had a meeting of the Galileo science team during a period in the doldrums after the Challenger accident when NASA was unable to launch the mission. So we met once a year, kind of waiting and doing some science in the meantime, and he came to one of these meetings. He didn't usually. It was great to have him there. He was wonderful at responding and talking about the science, and so at the end of the meeting, we went around and asked everyone what they planned to do during the next year to contribute to the science. And we came to Carl, and he thanked us. He said it was really great to be there. He'd really enjoyed interacting, but frankly, he would not be able to do much work on the Galileo mission during the next year because he was very much occupied with saving the world from nuclear war. It was a short pause, and then we all agreed, yes, that was okay. One of the things, of course, that occupied him so much late in his life in particular, was the struggle against pseudoscience. Such a difficult task, one that he was uniquely able to do because he had the scientific stature. He was known as a teacher, and he could address these problems that others here have spoken of also. I think his book, The Demon-Haunted World, is his greatest contribution. And I want to quote one thing from it. There are so many quotable things from Carl. But he said that finding the occasional straw of truth awash in a great ocean of confusion and bamboozle requires vigilance, dedication, and courage. But if we don't practice these tough habits of thought, we risk becoming a nation of suckers, up for grabs by the next charlatan who saunters along. Obviously, a message very much applicable today, and maybe especially appropriate to be given here in Washington. Things really have gotten bad in many ways, and we all know that. It's not just the charlatans, it's the people who are trying to pursue political ends and distort science in order to make that possible. I think sometimes, what would Carl be doing if he were still here today? Would he be able to be any better at fighting against the tide of ignorance and superstition than the rest of us? I'm not sure. We have fine people like Neil Tyson who are wonderful spokespersons for science, but they tend to get drowned out just by the sheer volume of lousy material. Carl could be on television when there were only 3 channels. And so you had a 1/3 chance that you would see him. Now there are hundreds of channels, and any individual can easily be drowned out. I do want to comment, though, at the end on the tremendous optimism that Carl had, not just about our ability to think rationally about a broad range of things, but that science was going to go places. I had the honor of doing an update, a chapter in the reissue of The Cosmic Connection, which John Lunine just talked about, and compared what Carl was writing with reality as it seems now 30 years later. And I was struck by how optimistic he was. He believed that by now we would have human colonies on Mars and the Moon. He believed that we would be sending spacecraft to the outer solar system every year. He believed SETI would have succeeded, and we would be in contact with extraterrestrial intelligence. He had a vision that was wonderful to read about. I can see how John Lunine was so inspired by cosmic connection. And we still have great visions, but they're not quite the same. And I asked myself sometime, if Carl had lived, would he have been able to make a bigger difference in carrying us forward in science and in public discourse, something that we all need so badly? If I have 1 minute, I'm going to show my own slideshow. It sort of pales by comparison with what you just saw. But these are my personal slides of Carl. In chronological order, starting back in his days at Harvard. There was a very short period in time at Cornell in '69 when he wore a mustache. Here he is with Gerard P. Kuiper, his thesis advisor, and also, with his back to us, Steve Soter, who will be talking in a few minutes. Many of you may know that he started his campaign against pseudoscience quite early, and in 1974, he sponsored a meeting of at the American Association for the Advancement of Science with Immanuel Velikovsky, the pseudo-cosmologist. Here he is in '74 with some of his students, and with Jim Pollack, his longtime collaborator. Together they did so much of the profound science on the atmosphere of Venus and on windblown dust on Mars. This is with Hans Mark, the director of NASA Ames Research Center, at the dedication of the Kuiper Airborne Observatory. This is Viking. I was standing under the monitor while these folks were seeing the very first pictures from the surface of Mars and looking up at that monitor. In the Voyager era with Ed Stone, the chief scientist, a picture with me at the same time as Voyager. That is me, by the way. And this one I like. Now, if any of you don't know, this is what scientists really do when they get a scientific insight. Another view, Carl, of course, attended a lot of scientific meetings, and it was always wonderful to have him there. At a birthday, we're now getting up into more recent times. This is the last picture I took of Carl with his longtime colleague Frank Drake in 1994. I miss him. I loved him. I wish he were still here, but it's so nice to have this symposium to remember him. Thank you.
Please welcome to the podium Dr. Bill Nye with his message of Carl Sagan Saved the World, and me along with it.
Good morning. It really is an honor to address you all. Through an old but serviceable telescope from our front yard, right here in Northwest Washington, my father showed me the moon and the planet Saturn for the first time, and I shall never forget it. Seeing those objects up close changes you, and so it was with Professor Sagan's astronomy class. It changed me every bit as profoundly as the craters on the moon or the rings of Saturn. He empowered us. Indeed, he emboldened us to come to know our place in the cosmos, our place among the stars, what I like to call our place in space. Every day in his class, there was something astonishing to behold. He showed us pictures from Mars that no one outside of the Jet Propulsion Laboratory had seen before. He challenged us to figure out just what you'd have to do to really find life on another world. Along with that, he demanded to know what record best suited to inclusion on the Voyager spacecraft. And we strongly suggested Johnny Be Good. It was in his class that I became aware for the first time of the Tunguska airburst event, the remarkable, terrible, destructive power of an impacting asteroid or meteoroid. It's an issue that our leaders today are just beginning to understand. They're just beginning to see that it's a small step from impactor science fiction to impactor science fact. Now here's hoping we can imagine the consequences and just not let an impact happen. I wrote a paper for Professor Sagan about the paranormal illusion called Kirlian photography. Pictures of imaginary life aurae, or auras, halos. In other words, although it was a class about astronomy, my final paper was about pseudoscience, a topic seemingly unrelated to the stars. But Carl Sagan wanted me, to know and appreciate the process of science much more than the facts of astronomy. He made me a skeptic. He made me a critical thinker. He changed me. It was Carl Sagan who introduced the phrase comparative climatology to us and to the world. And when we made these comparisons in his class, we came to behold that our Earth is not just a special case, but is astonishingly special. Carl Sagan's insights showed the world that the greenhouse effect is a terribly important thing to understand. After having spent a great deal of time with the notion of comparative climatology over the last 33 years, I can remind anyone that virtually every mathematical climate model that we have today can trace its beginnings to Carl's work on nuclear winter. His first set of assumptions, his first set of insights as to what's important in such a model are still with us today. It really is remarkable. As an educator, an engineer, a citizen of the Earth, I hope that we soon stop denying and start doing all we can to slow climate change and mitigate the consequences of our soon-to-be displaced populations. I came of age as an engineer in a world that featured the Ford Pinto, an older reference lost on many of the younger listeners, the Chevy Vega, leisure suits, the removal of a perfectly functioning solar hot water system from the White House roof, and the decision to launch the Challenger space shuttle on a particularly cold day. I was troubled by my country's willingness to embrace the mediocre. I often felt Professor Sagan was troubled by this trend as well. And by the time of my 10th college reunion, I was fired up to do a television show for children about science because of what I had viewed as the short-sightedness in everything. In government and in industry, I wanted to influence kids so that we might have a more scientifically literate society for a better tomorrow for all of us. It took a letter and several phone calls to arrange a meeting with my old professor, who probably had no idea what an unremarkable former student would want from him. But he agreed to meet with me, and by all accounts, he took the time to meet with almost anyone who made a good case for it. In those 5 minutes, he once again changed my life forever. In short, he said that he could see that I loved engineering, the business of using science to make things and solve problems, but he encouraged me to focus my educational work on pure science. He said, and I shall never forget it, he said, "Kids resonate to pure science." That sentence redirected me. It led directly to what became the popular Bill Nye the Science Guy show, and it's quite a thing for someone to utter just one thought and change a man's life. I will be forever grateful. Professor Sagan told me in so many words, mine was a good and worthy pursuit. Kids resonate to pure science. With the tremendous, almost incredible success of both the Viking missions to Mars and the Voyager missions to our neighboring worlds, Carl and his colleagues became very, very concerned that government support for robotic missions of this sort was drying up at the very moment in history when we should be investing more and pressing farther and deeper into space. So he and Bruce Murray, who was the head of the Jet Propulsion Lab at the time, and Lou Friedman, a Jet Propulsion Lab employee, formed the Planetary Society. It quickly became, and still is, the world's largest non-governmental space interest organization. And they formed this at what they thought was a crossroads in the history of the exploration of space, and I suggest we are at another crossroads that's very, very similar. So as a former student, I guess, I was put on the mailing list I joined and became a member. Then 3 years ago, something happened. I left the room or something, and I came back, and now I'm the CEO. Now, the Planetary Society is growing for the first time in many years, and we're going to at last fly 2 solar sail missions. Solar sail missions were something near and dear to Carl's heart. So I can say that as an engineer, as a professional, and as a citizen, Carl Sagan's legacy is part of me. Now, looking around and being part of this event today makes me wonder that perhaps Carl Sagan's life's work is just now bearing new fruit. He inspired enough of the Earth's citizens to take our place in space seriously, to know and appreciate the fragility of our world, that we have so far avoided a nuclear weapon war, that we started thinking about the climate of Mars and especially the climate of Venus as compared with the climate of Earth, that his landmark television series is being updated and broadcast to new generations. There are more science websites today than ever in history, more science interest than in the last 30 years. Perhaps this new fruit will help us, dare I say it, change the world. Perhaps we've begun a new enlightened era of scientific discovery, and that will soon include people everywhere. Although it has taken decades, Carl Sagan may yet save the world as we know it. With his class, his advice, his science, his planetary society, he utterly changed my life, and I am so very grateful. Professor Sagan helped me come to know that we all are part of a greater whole. The greatest whole that seems to be, the cosmos. You changed the world, Carl Sagan. Thank you, and thank you from all of us here on Earth. Let's go forward, and dare I say it, change the world in his name. Thank you all very much. Thank you.
Please welcome to the podium Dr. Carolyn Porco with her message, Carl, this one's for you.
Good morning, everybody, or good afternoon. No, it's still morning. And thank you very much for having me here. I'm very glad to be here, and you will soon see why. I met Carl also back in 1972 when I was an undergraduate, but came to know him best when we were fellow members of the imaging team on the Voyager mission, which toured the outer solar system during the 1980s. And I have to tell you, those were incredibly thrilling times. For a young person on her first professional assignment to be there in this historic exploration of the outer solar system, and to watch Carl and all the senior imaging team members try to tease out what it was we were seeing for the first time in history on the worlds and among the rings and so on in orbit around Jupiter, Saturn, Uranus, and Neptune. And it was also quite challenging. I was, after all, the youngest person on the team. And many times during those years, I found myself the recipient of Carl's encouragement and kindness. And perhaps he must have noticed that I needed it, because he often went out of his way to offer it. And there's just one example that I think of. I'm remembering a particular team meeting where I was desperately trying to make a point that I'd hoped the other imaging team members would find profound and unforgettable. And in doing so, I gestured so wildly that I smacked the person sitting next to me in the face. And afterwards, Carl came up to me and told me how nicely I had behaved. I don't know, maybe he thought the guy deserved it, but anyway, I have a lot of happy memories like that of interacting with Carl. And some of the best happened when I had the chance to work with him on planning and executing what has become, it is now the famous pale blue dot image of Earth taken by Voyager 1 in 1990 from beyond the orbit of Neptune. And as Carl had described it, in a proposal to the Voyager project. The idea was to take a picture of the Earth awash in a sea of stars. Well, the actual pale blue dot picture was not really what we had envisioned. As great as it was, there are no stars, and it ended up showing the Earth smack in the middle of a beam of light that was produced by light scattering in the optics of the camera. Of course, none of this really mattered, because it was what Carl had to say about this image and the way that he turned it into a romantic allegory on the human condition that made its name, pale blue dot, made that phrase now synonymous with an inspirational call to planetary brotherhood and protection of the environment. Well, since the very beginning of my tenure as the leader of the Cassini imaging team at Saturn, I had in mind to do this picture all over again, only make it better. And I thought, somewhere along the way, I thought, wow, wouldn't it be great if we could take the opportunity of a spacecraft imaging the Earth from 1 billion miles away and get everybody involved, get everybody to participate in it, invite them, let them know ahead of time, at this time, your picture is going to be taken from Saturn, and go outside when this is happening and look up and contemplate the utter isolation of our planet in the never-ending blackness of space, and appreciate, think about its rarity, its lush beauty, and the rarity that it is among the other planets in the solar system, and marvel at your own existence and the existence of all of life on Earth. And so it happened. On July 19th of this year, only 4 months ago, the Cassini cameras were turned to look back at Saturn while it eclipsed the sun, to take another pale blue dot picture of Earth. And we had sent out the word, go out and look up and think about this incredible accomplishment of this interplanetary interplanetary salute between robot and maker that's about to happen, and smile. And so people did that. It turned out to be tremendously successful. We got a lot of comments of people. They felt exactly like I was hoping they would feel at the moment our picture was taken. Here's just one of my favorite comments from someone in upstate New York. I've been entranced by this project ever since I heard about it and was determined to join in the celebration. We may not be unique, we may be transient, we may be only flying along on a dust mote in space, but darn it, for 15 minutes, we were there, we were aware, and we smiled. So after much work, today, this morning, we are officially releasing the mosaic that was taken of Saturn at the time that the Earth smiled in unison. And so in honor of Carl, here it is, my friends, our gift from all of us on the Cassini Project and NASA to all of you, the picture of the picture of the Saturn system taken as the Earth smiled in return, showing Saturn eclipsing the sun, its main rings backlit by the sun, and this glorious blue ring, which is created by the spray of 100 geysers erupting from the south pole of the small icy moon Enceladus, shown right there. Enceladus has become, in the eyes of Cassini, the most promising place in our solar system to examine whether or not life has gotten started. And finally, and I hope this works, we need the movie now, looking over the shoulder of Saturn, 1 billion miles in the distance, is the pale blue dot of our planet Earth. We need the movie. Let's hope it works. Here we go. And we get closer, we see there Earth 1 billion miles in the distance. And as we get even closer, as we could with our high-resolution cameras, for the first time from the outer solar system, the Earth and the Moon, seen as separate, distinct objects. Thank you. As evidenced by your reaction, there is something undeniably powerful about seeing a sight of our own fragile little blue ocean planet as it would be seen in the skies of other worlds. It's a shocking, uncorrupted recognition of ourselves as we truly are. And it's a recognition that seems never to fail to move us. And it moves me to think about evolution. I look at this image, and I see our distant ancestors stepping down from the trees and walking upright for the first time onto the African savannas and pausing to look back at the forests from which they came. And I see a species that is positively unyielding in its pursuit of knowledge and brave in its longing to grasp the meaning and the significance of its own existence. And finally, I'm not going to make it. I can't help but look at this image and see the very best that humanity has to offer. We are, beyond question, the troubled and warlike inhabitants of one tiny little dot, but it serves us well to remember that we are also the thinkers, the dreamers, and explorers who took this picture. One world clear across interplanetary space to another. And to be so small and reach so far is what makes us the incredible, the extraordinary citizens of planet Earth. And as Carl himself told us over and over again, there is sufficient spiritual nourishment in that to last all of human existence. And so, in honor of his groundbreaking contributions to the genre, I want to personally dedicate this image to Carl Sagan. Carl, wherever you are right now, somewhere out there in the cosmos, no doubt, this one is for you. The Earth awash in a field of stars, just like you wanted, and billions of thank yous for your friendship and support. It's been my pleasure. Thank you.
Please welcome to the podium Dr. Stephen Soter with his message, Carl Sagan as a Candle in the Dark.
Thank you. I'm very delighted to be part of this celebration. I first met Carl in 1968 when I was a student at Cornell. I already knew that he was an inspired proponent of astrobiology, and I was thrilled when he arrived to join the Cornell faculty. We became good friends right away. I learned that he was not only a gifted teacher, but also that he believed in the social responsibility of scientists. I saw this, for example, when he invited me to work on the original Cosmos series. At that time, the nuclear arms race with the Soviet Union was heating up again. Carl decided he would use the final episode of the series to describe the danger to civilization and to offer a heartfelt plea on behalf of sanity and survival. Hundreds of millions of people around the world watched that episode, and many of them surely took it to heart. In the following years, Carl worked tirelessly to explain the threat of nuclear winter and the destabilizing danger of the proposed Star Wars scheme. Mikhail Gorbachev personally told him that the studies of nuclear winter had strengthened the case for deep cuts in the nuclear arsenals. Carl made a real contribution to ending the Cold War. He often used his popularity to promote the values of critical thinking. The unique power of science flows from what he called the marriage of skepticism and wonder. Carl taught that we must be open to new ideas and at the same time subject them to the most rigorous critical scrutiny. We should question authority and require credible evidence in support of all claims to the truth. Since Carl's untimely death in December 1996, I've often imagined how he would have responded to subsequent events in areas that interested him. I think I knew him well enough to have a pretty good idea. The first time this thought occurred to me was in March 1997, when comet Hale-Bopp appeared. You may remember that 39 members of an apocalyptic cult called Heaven's Gate committed mass suicide in the delusion that it would take them to an alien spaceship trailing the comet. They had even bought an expensive telescope to watch the comet. They saw no spaceship, so they returned they returned the telescope for a refund. Maybe they thought it was defective. Magical thinking trumped direct evidence. No one questioned the authority of the cult leader. I remember thinking that if Carl were still alive, the major media would have scrambled to interview him, and what a teaching moment he would have made of that tragedy. More recently, I imagined how Carl would have responded to the recognition that Pluto is, after all, not a planet. I can hear him saying that science is not a doctrine graven in stone, but rather a living process to understand the natural world, a way of thinking that welcomes new evidence and openly admits and corrects its mistakes. I can think of many other times when I wished we still had Carl to enlighten the scene, especially concerning the trumped-up controversy over climate change. I believe Carl would have profoundly altered the landscape of opinion on this issue. He was deeply versed in the science. As far back as 1960, he was already on to the runaway greenhouse effect for Venus. In our own time, he would have relished the task of exploding the bogus arguments of the climate cranks and deniers. He would have done it gracefully and with good manners, for that was his way, but he would have handed them their heads on a plate. If Carl were still among us, I really doubt that so many elected officials and editorial writers could get away with claiming that climate scientists don't know what they're talking about. The last few years have witnessed an attack, unprecedented in our time, on the integrity of science itself. The world's climate scientists are accused of perpetrating an alarmist hoax. 37% of the voting population in this country believe that. Some climate scientists have even been harassed and threatened. Carl would have been appalled, and he would have spoken out sharply. He recognized the danger signs. In his final year, while very gravely ill, he brought out a book called The Demon-Haunted World, subtitled Science as a Candle in the Dark. Carl envisioned scientific thinking as a candle illuminating a region of clarity, but one still surrounded by the darkness of magical thinking, ignorance, and fear, cultivated by greed and self-deception. It was only the scientific enlightenment that had put an end to the burning of witches and heretics, and we have no guarantee that the change of outlook is permanent. Carl left us with this warning, quote, "Whenever our ethnic or national prejudices are aroused, in times of scarcity, during challenges to national self-esteem or nerve, or when fanaticism is bubbling up around us, then habits of thought familiar from ages past reach for the controls. The candle flame gutters, its little pool of light trembles, darkness gathers, the demons begin to stir." He also said, "We must not let it happen again." Our world was impoverished when we lost Carl 17 years ago, but I feel grateful for all the years when we did have this courageous, compassionate, and wise man at our side. And I celebrate, along with all of you and this magnificent National Library, the generous spirit and brilliant legacy of Carl Sagan. Thank you.
And now, the opening moments to the Cosmos program.
The cosmos is all that is, or ever was, or ever will be. Our contemplations of the cosmos stir us. There's a tingling in the spine, a catch in the voice, a faint sensation as if a distant memory of falling from a great height. We know we are approaching the grandest of mysteries. The size and age of the cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planetary home, the Earth. For the first time, we have the power to decide the fate of our planet and ourselves. This is a time of great danger, but our species is young and curious and brave. It shows much promise. In the last few millennia, we have made the most astonishing and unexpected discoveries about the cosmos and our place within it. I believe our future depends powerfully on how well we understand this cosmos in which we float like a mote of dust in the morning sky. We're about to begin a journey through the cosmos. We'll encounter galaxies and suns and planets, life and consciousness, coming into being, evolving, and perishing. Worlds of ice and stars of diamond, atoms as massive as suns, and universes smaller than atoms. But it's also a story of our own planet and the plants and animals that share it with us. And it's a story about us, how we achieved our present understanding of the cosmos, how the cosmos has shaped our evolution and our culture, and what our fate may be.
Please welcome to the podium Dr. Kip S. Thorne with his message, Carl Sagan's Impact on Me, From Wormholes to Floaters to Science Communication.
Could we bring up the slides, please? Well, while they're trying to do that, let me begin. In the early 1970s, Carl was a recently tenured professor at Cornell, and I was similarly a recently tenured professor at Caltech. Carl was spending a lot of time out in Pasadena, preparing for the Pioneer missions, the Voyager missions, other missions to the planets. I was spending a lot of time at Cornell because they had a great astrophysics program there, really interesting people to talk to. And so it was natural that Carl and I became good friends. One of my other close friends from that era was Ed Salpeter at Cornell. Now, in December 1976, the latest version of the Astrophysical Journal, sort of the New York Times of astronomy journals, landed on my desk. And immediately, my eye gravitated to an article by Ed and Carl entitled Particles, Environments, and Possible Ecologies in the Jovian Atmosphere. This 19-page article began with 10 pages of very careful, detailed analysis of the physics of Jupiter's atmosphere. Just what I would expect of Carl and Ed. Just what I would expect in the New York Times of scientific journals. But then it was followed by 9 pages of speculations about life forms that might exist on Jupiter. I was blown away. I had never seen an article speculating about alien life forms, and not in the Astrophysical Journal. They talked about sinkers. This is from Cosmos, Carl's later vision of what it would look like. Sinkers, microorganisms that are kept afloat in the Goldilocks zone, not too hot, not too cold, of Jupiter's atmosphere, long enough to evolve, to replicate. They talked about floaters, large bags of gas that floated in the Goldilocks zone, kept aloft by buoyancy. They talked about hunders, which of course hundred the sinkers and the floaters. And this article was coming in an era when astrobiology hardly existed at all, when in polite circles it was very disreputable, and yet they published this article, they got it published, and you could understand why when you saw the wonderful physics of the atmosphere and the logical deductions that they were able to make, and the ultimate conclusion that if life forms could exist on Jupiter, then you better be very careful about sterilizing your spacecraft if you're going to send spacecraft to the vicinity of Jupiter. Fast forward some 9 years, and I received a letter from Carl, a letter and also a telephone call in which he asked me to look at the manuscript of a novel called Contact that he was working on. He sent me the novel. I was very eager to read it. I read it with great enjoyment, but he had asked for my critique. And there was one item that I did critique on it. He had his heroine, Eleanor Arroway, traveling through a black hole to get to the vicinity of the star Vega, and then returning. And this was an area of my expertise, not of Carl's, and that's why, of course, he had sent it to me. And so I sat down and wrote a letter to Carl explaining what the issues were with this. That, as is shown here in a drawing by the artist Leah Halloran, that a black hole is something that has no connection to another part of our universe. Here you visualize our universe as being like a two-dimensional surface. This is a piece of the universe coming back there in a higher dimensional space. The black hole is a one-way membrane. The surface of the black hole is a one-way membrane. You can go in, you can't come back out. And once you go in, you're killed in a singularity that sits at the center of the black hole. A wormhole, I told him, by contrast, and there had been just a little bit of speculation and some mathematical studies of wormholes in general relativity theory, a wormhole would be a route that could lead you through hyperspace to another part of our universe, hypothetically. But then I went on, as a result of some calculations I did stimulated by Carl, and I sat and did calculations for a day based on stimulated by Carl's question. The wormhole would have a problem that the wormhole would pinch off before you could get through it if you did not thread through the wormhole material that has negative energy. But I knew that quantum theory allows, amazingly, material with negative energy, but only tiny amounts for brief periods of time as a result of what are called quantum fluctuations. And I explained this in my letter to Carl and said that we really don't know whether you can get enough negative energy material or exotic material in the interior of a wormhole to hold it open, but that's your only route out of the solar system if you want to do it quickly and come back. And so Carl very graciously thanked me and rewrote pieces of his novel in page proof, not much to the dismay of his publisher, I'm sure, and thereby wormholes entered modern science fiction. But more importantly for me, thereby I was triggered to think about issues that were more disreputable in that era than astrobiology had been a decade earlier. I spent 3 years thinking about wormholes on and off, thinking about their consequences, and along the way I realized that if an advanced civilization had a wormhole, it would be possible for that advanced civilization, according to general relativity, to convert that wormhole into a machine for traveling backward in time. I sat down with 2 of my students and we did many long calculations about this and about other aspects of wormholes, and then encouraged by the example of Carl and Ed a decade earlier, we got up our courage and wrote a paper and amazingly got it published. So this, by the way, is one of my treasured possessions. It's the letter, it's a copy of Carl's novel Contact with his inscription thanking me for the ideas about wormholes that I had sent to him. But 3 years later then, we sat down and we wrote this paper, Wormholes, Time Machines, and the Weak Energy Condition. managed to get it published with very little opposition. I was just amazed at how quickly it got through the refereeing process in the Physical Review Letters, sort of the New York Times of the physics community. Then I waited for the reaction. And I had reaction that ranged from, are you going out of your mind, to enthusiasm. Fortunately, over the long haul, the enthusiasm won out. And over the next decade, nearly 1,000 papers were written following up on the ideas that we had thrown out in this article, including the one that was most memorable. Oh, let me just say, describe what our attitude was about that research. This was the very first sentence in our article. It says, normally, theoretical physicists ask, what are the laws of physics? Or what do those laws predict about the universe? And in this paper, we ask instead, what constraints do the laws of physics place on the activities of an arbitrarily advanced civilization? This will lead to some intriguing queries about the laws themselves. And those roughly 1,000 articles that followed on were using these kinds of thought experiments then to try to understand what the laws of physics say in extreme circumstances where we don't yet have the capability of doing experiments. One of my favorite articles that was a follow-on from this was by Stephen Hawking, his chronology protection conjecture, in which he presented a variety of arguments as to why you cannot have backward time travel, thereby keeping the cosmos safe for historians, as he liked to say. Let me wind up with a few words about science communication. In 1977, I bought and read avidly Carl's book, The Dragons of Eden. It was a science communication. It was not science fiction. It was about speculations on the evolution of human intelligence, but the science writing was superb. And this was my first encounter with his science writing because I was in a rather different field than he was. That book still sits on a bookshelf above my bed in the dacha in Oregon, where I go to hide and write when I want to be left alone, as an inspiration to me as to how I would like to write. I would like to emulate Carl's superb science writing. In 1994, I published my first book for the general public, Black Holes and Time Warps. And Carl was very generous when I sent him the manuscript a little bit earlier. I requested his critique. I got 4 pages. Some of it laudatory, not all of it laudatory. Wonderful suggestions, wonderful advice. I also have greatly admired not only Cosmos, but also his movie version of Contact. I don't know how many students of the later generation in the 2000s came to me at Caltech and mentioned how influential the Contact, the movie, had been on them, inspiring them to pursue careers in science. Contact was a collaboration of Annie Druyan and Carl. A major player in this also was Linda Obst, their producer. One of the nicest, most important things that Carl ever did for me, was to introduce me to Linda. Linda and I have now formed a collaboration to try to follow in Carl's footsteps, to create fiction film that utilizes and builds on the very frontiers of science, thereby inspiring the next generation of young people to become interested in science and perhaps pursue such careers. So for all of this, Carl, wherever you are, I thank you.
Please welcome to the podium Dr. Neil deGrasse Tyson with his message, Carl on My Mind.
I don't have slides. It's just, you're stuck with me for 7 minutes. My story is not that different from so much of what you've just heard. It's spiritually the same. Details are different. My first encounter with Carl was not, in fact, derived from a letter that I wrote to him, as we heard from Jonathan. In fact, it was a letter that he first wrote to me. I was in high school, 17 years old, applying to colleges. I knew I was interested in the universe, no question about it. That happened from a first visit to my local planetarium at age 9, the Hayden Planetarium in New York City. The lights dimmed, the stars came out. I first thought it was a hoax. That's too many stars. I know how many stars there are. I've seen all 14 of them from the Bronx, right? That's where I grew up. This is not true. I'll go along with it for the half hour that we're there, but I know better. So my interests were deep and established. So I applied to colleges. One of the colleges I applied to was Cornell. And little did I know that the admissions office had taken my application, forwarded it to Carl's attention. He then wrote a letter to me, out of the blue. This is about space. We get to say out of the dark, right? Not out of the blue. This letter shows up in my mailbox. Carl, is this the same Carl Sagan? This can't be the same. No, how could this be? I just saw him on Johnny Carson. It can't be the same person. Famous people don't write out of the blue to strangers. They're too busy. They got too much else on their plate. Opened the letter. It was from Carl Sagan, inviting me to visit the campus to help me decide where I might choose to go to college. So then I thought in my denial, this is just famous people talk. They don't really mean it. Like when I first met Seth MacFarlane, we exchanged emails. I didn't expect he'd ever call me. 2 years later, hey, Neil, this is Seth. Seth who? You know. Famous people don't call non-famous people. The invitation was real. Took the bus up to Ithaca, New York, from New York City. It was December 1975. He met me in front of the building. He's there. The campus was mostly empty. I think we'd already entered Christmas holidays, but he was there. Invited me up to his office. We talked about the lab, his work on Voyager. Here's my favorite part. He reached behind him. He didn't even look. Just reached behind at his desk, pulled out a book that he wrote. I said, that's really cool. You don't even have to look. And wherever your hand lands, there's a book that you wrote, right? So I just thought, and he signed it to me. The same book, Cosmic Connection. Except mine was a paperback, sorry. He had the hardcover. To Neil, future astronomer. We were done. He drove me back in his car to the bus station. It begins to snow. It does that often in Ithaca, New York. At that time of year. It begins to snow, and it's not obvious if the bus is going to come through. I wasn't thinking about this, but he was. He said, here's my home number. Call me, spend the night with my family if the bus can't make it through. And I was like, whoa, who did I just have an encounter with? I don't know, what is this? To this day, I model my behavior and my attention that I give to students based on that first encounter with Carl. I could be on the phone in my office with the White House. A student shows, I say, Barack, I got to call you back. I got a student. You know, I only met him 4 times. We weren't beer-drinking buddies or anything. Only 4 times, that was the first. A second encounter, 17 years later. It was a meeting held in Virginia, Westfield Conference Center, to talk about NASA's future. What are the goals that the then new administration would have for NASA? Carl Sagan organized it, brought together some of the greatest communicators of our time. At the time, I thought I gave a pretty good talk. I thought I communicated pretty good. And I go there and I'm in the company of the greatest communicators I had ever heard, and I found out I was just average, or a little below average. There were people with who articulately conveyed exactly what they thought and exactly what they meant, and it was interesting and I wanted to learn more. We all got together to talk about, what is NASA's mission? Is it just to beat the Russians? Is it to inspire? Let's lay this out. That was my second time that I'd met him. Third time was his 60th birthday, back in Cornell. A couple of hundred people in attendance. I was honored to have been invited. I only met the guy twice. And over dinner, there were these accolades that just kept coming from students and teachers and friends and loved ones and students and teachers again and colleagues, and it just kept going and going. And these were praises that normally you only hear after someone is dead. There's an old saying, exaggeration is allowed after someone has died. You don't have to be completely truthful because you're trying to reflect on all that was good about a person. This was happening in Carl's life. It would be 2 years later he would die. We're hearing testimony as though someone had just died and everyone is summoning up only their best thoughts to share. And I'm thinking, could anyone be worthy of this much praise in life? Yes, in death, 10 years later, you say great, but in life, is that even possible? After that dinner, he gave a public talk in the largest auditorium on the Cornell campus. We're all there. He gives a riveting, compelling, scientifically informed, intellectually accurate, emotionally honest talk about our place in the universe. To this day, it was the greatest performance I had ever seen. And every minute through that lecture, I'm thinking, yes, he has deserved everything I just heard. This person is real. We didn't just imagine this up in death. They're accurate recollections in life. I was influenced by this man because I said, if I'm ever a science communicator, I want to be that compelling. There was a fourth encounter I had with Carl. That was at his eulogy. There were 2, West Coast and East Coast. I presented at his eulogy, Cathedral of St. John the Divine, New York City, my hometown. Why was he there? He was there. I'm remembering the novel Rebecca, published 1938 by Daphne du Maurier. 2 years later made into a film. What's interesting about that story? Rebecca, the title of the movie describes the main character of the story, and the main character never is there. The main character is dead. And you assemble what you know of her from everyone's recollection from the beginning to the end of that film. She is more real than anything else. Because who are we if not measured by our impact on others? That's who we are. We're not who we say we are. We're not who we want to be. We are the sum of the influence and impact that we've had in our lives on others. So several of you have asked, wherever you are, Carl is here right now. Thank you.
Please welcome to the podium Dr. Ann Druyan with her message, A Way for the Universe to Know Itself.
Well, the first thing I should do is disabuse you of the notion that I am a doctor of anything. I am just Annie. And it's such an honor, a thrill, to be here with you. Could we turn the lights down so I could see you? Because I know that so many of you were deeply loved by Carl. I'd like to single out some members of his family, our family, who are here today. His son, Jeremy Sagan. Please stand up, Jeremy. Our daughter, Sasha Sagan, please. And the granddaughter he never knew, Sarah Sagan. I'm so thrilled to have you here. And I also want to single out two other people. As you all know, Carl succumbed to a disease called myelodysplasia after 3 bone marrow transplants over a 2-year period. And his sister, Carrie Sagan Green, was the completely unstinting, open-hearted donor for those 3 transplants. And I remember that phone call because I was on one of the extensions. And Carl said, Carrie, I'm sick. I need something. And before he could finish the sentence, she said, you got it. Liver, heart, lung, whatever it is, you got it. So Carrie, please stand up. And if you'll allow me personal indulgence, I would also like my wonderful father, Harry Druyan, to stand up, because it was he who prepared me for this wonderful life of love. He and my mother instilled in me this sense that life was a fantastic adventure and that love was the greatest gift within it. And so I thank you for preparing the way. Some of the happiest times of my whole life were watching my father and Carl sitting on the front porch of our house in Ithaca. My dad is our next door neighbor. And just watching the two of them with their arms around each other, looking out at the lake and laughing. Carl's laugh is one of the most precious memories that I have. And it's a great thrill to me that on the Voyager records, the most distant objects ever touched by human hands Carl's laugh is preserved forever. It sounded like something you would only hear in a mental hospital. It was, it was the most free and completely unself-conscious laugh, the laugh of somebody who lived completely. There was no part of him that was stunted or unexplored or unexpressed. The joy of thinking with him for 20 years. This is a man who read a book a night. And so the idea that his papers, his scientific papers, the manuscripts of his Pulitzer Prize-winning writing, Cosmos, Contact, those articles in Parade magazine, all of that work, our shopping lists, everything is here, kept with the papers of those he admired most. You know, this drawing made on a really probably tattered rug in a tiny living room in a cramped apartment in Bensonhurst during the Second World War. He was the child of a cutter in the garment district, and his mother, Rachel, was a homemaker. And Rachel and Sam had very little in the way of formal education. Sam had some. But they were readers and searchers. And they loved their children fiercely. And when Carl asked a question that Rachel and Sam couldn't answer, Rachel took him by the hand to a public library, Brooklyn Public Library, so that he could get his first book about the stars. That's where the trajectory to Voyager and to 1 billion years of wandering the galaxy, that's where the trip from the kid whose parents have never met a scientist to someone who comes to mean what science is at its best in every country on Earth. It all begins with that hand holding that little boy and saying, let's find out together. I want to thank Seth for your absurdly lavish praise of me, most of all, but also for preserving more than 1,000 boxes of the life output of a man who wrote 2-page letters to kids with an interest in science. The man who sounded the alarm on nuclear winter, on global warming, and on our failures of education. Carl would teach Sasha's kindergarten class and others. He would rev up the teachers on the night before school started, the teachers of Tompkins County, get them together on a beautiful September night and plead with them to remember at all times this sacred duty of inspiring future generations of searchers, of inducting a new generation of children into the 40,000 generations of our searching. I'm thinking about the talk that Neil alluded to. I think it was the greatest talk he ever gave, and I was so fortunate to witness countless talks. But it was a tour de force. Carl never made any notes. He spoke in meticulous paragraphs that could be published without any annotation or abridgment. And this talk was so moving. He was 60 years old, and he was talking to this packed audience. And of course, the favorite time for him was when the question and answer period began. And one young man got up and he said, what have you left us with all what you call these great demotions? Earth's not at the center of the solar system not at the center of the galaxy not at the center of the universe, human beings here for only the last 15 seconds of the great cosmic year of 13.8 billion years. Where is the meaning? And Carl looked at him and he said, do something meaningful. And that was at the heart of his whole life. All of the wonderful speakers who've attested to how generous he was, how conscientious he was, what a great scientist he was. He took a lot of abuse because he wanted to connect with everyone. He really believed in democracy. He had come from nothing, and he really believed that the more people who could have this powerful information about where we are and when we are and who we are in the universe, the better society we would have. And so he was indefatigable in trying to spread the word. That's another reason why I'm so thrilled that his papers and ours are here. Because Carl could have gotten into the Hall of Fame like Babe Ruth. He could have gotten into the Hall of Fame if he'd just been a pitcher. He pitched more winning games if he'd never, ever hit one single home run. Well, Carl could have gotten into the Hall of Fame just as a human being and as a citizen. And it was a passionate act of citizenship combined with a brilliance and an insatiable curiosity. And more than anything, an appreciation for the amazing good fortune that we all have to be alive at this moment in a cosmos so ancient and so vast that we've all found each other, found our way to each other here today, is how I look at the world. I feel like the luckiest person who ever lived to have made 20 trips around the sun with Carl Sagan. They'll last me the rest of my life, everlasting joy. And the pride that I feel in his life and what he sought to do with his precious time overwhelms me with joy. Thank you for your wonderful talks about Carl, for bringing him alive, as Neil said. And thank you for keeping his flame burning. My dream, the thing I would like most to come out of this, is if there could be a bureau of science exciters. Carl Sagan's, Neil Tyson's, Bill Nye's, people who know how to connect with the largest possible audience. Send them to those states that shall remain nameless, but who we know who they are. Send them. Okay, so we're tapped out. We don't have enough money right now to create the same kind of public education system that we once had when Carl was a kid. That's what made Carl Sagan what he became. Let's send those science exciters to every one of those states with really sexy visual aids so that people won't think too carefully about what they're saying. And let's cast that net, because I know there are more Carl Sagans out there. Thank you very much.
That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, Every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
This has been a presentation of the Library of Congress. Visit us at loc.gov.